All right, so we're working with reciprocal identities, okay? I want you to just understand the difference between them, okay? The cosecant is the reciprocal of the sine. The sine is the reciprocal of the cosecant. Okay, they're reciprocals of one another. Sine, we know, is opposite over hypotenuse. So cosecant would be hypotenuse over opposite. Okay? Good with me on that? Okay. Have you guys written down the rest of them? Because I'll write them just for the video's purpose. All right. Cosine of theta is 1 over the secant of theta, or the secant of theta is 1 over the cosine of theta. Okay, however you want to think of it. Haley, tangent of theta would be like what? Would be the same thing as what? 1 over the cotangent of theta. Good job. Okay. And Jack, the cotangent of theta would be what?
1 over tangent.
1 over tangent of theta. Okay? Everybody all right on those now? A little better? Okay? Then there were the quotient identities. Okay? The quotient identities. Okay? And was the first one tangent of theta equals sine of theta over cosine theta?
Yeah.
Okay? To help you remember this, maybe off to the side, draw this little picture here. Okay, well, why does this make sense? Unit circle. On a unit circle, how long is the hypotenuse?
1.
1. Tangent of theta is opposite over adjacent, right? Okay. So the tangent of this angle theta would be this opposite side over this adjacent side, right? Okay, we agree with that? All right. Sine of theta would equal what? Opposite over hypotenuse. Okay? So if I call this side y right over here for right now, would you agree that the sine of theta equals y over 1?
Yeah.
Would you also agree with me then that the sine of theta simply equals the y value? Because y divided by 1 is y. Yeah. And therefore, would you also agree with me that instead of labeling this y, couldn't I also just label it sine theta? Since y is equal to the sine theta? Yeah. So the length of this side of that part of the triangle would be sine theta. I kind of proved it to you right here. Take a wild guess how long this side of the triangle is.
X cosine theta.
X, but I could also write it as cosine theta, right? Okay? This side, for the same purpose, is cosine theta. So guess what the tangent of theta is equal to?
Sine theta.
Sine theta over cosine theta. A little bit of y, that is. So you're not just memorizing it. Okay? Another way you might think of it, tangent is y over x, right? Remember way back, tangent is y over x, like when you do your quadrantal angles on your time test and you think, okay, what is the tangent of pi over 2? Well, pi over 2, I got to go y over x. Tangent is always y over x. Well, just remember, y is always your sine value, x is always your cosine value, so it's always sine over cosine. Okay? And then, from that, wouldn't it be logical then? What would the cotangent equal?
Cosine theta over sine theta.
Because the cotangent is the what of the tangent? The reciprocal. So cotangent would be cosine theta over sine theta. Cotangent, cosine's on top. Okay, cotangent, cosine's on top. With the C's on top, okay? Help keep them straight if you just like little tricks to keep them straight. All right? But hopefully you can kind of think of this a little bit. So those are your quotient identities. All right? Good on those? Okay with them? If I asked you to simplify this expression, tangent of theta times cosine of theta. Let's simplify this. Let's make it look nice. There's two trig functions there. Let's make it look nicer. Let's write it as one trig function. What could maybe I replace tangent of theta with that might simplify nicely? If I'm going to multiply it by cosine theta, maybe what could I replace tangent of theta with so that it simplifies? Yeah?
Sine theta over cosine.
Isn't tangent theta sine over cosine? Isn't that one of the identities we just wrote down? So I could replace tangent theta with sine over cosine? So now I have sine over cosine times cosine over 1. What happens? Cosines cancel. What are you left with?
Sine theta.
Sine theta. So the tangent of theta times the cosine of theta could really just be written as sine theta. I don't expect you to memorize that. Okay, I wouldn't expect you to think, oh, well, that's really sine. No. But if I asked you to simplify this, I do expect you to know, well, that's really sine over cosine. So if I write that as sine over cosine and I take that times the cosine, I could simplify some things and I get it down to just sine. It's kind of like proofs. Okay? Kind of like proofs. They're just fun puzzles to solve. I love them. Okay? So that's what we're eventually kind of going to be doing. All right? Pythagorean identities. Pythagorean identities. Alright? There were 3 of them. Okay, there were 3 of them on page 423. Sine squared plus cosine squared equals 1. Tangent squared plus 1 equals secant squared. 1 plus cotangent squared equals cosecant squared. Okay? You will have to know all those. Okay? I don't have them memorized. I have one of them memorized. That's all you need. That's all you need. Because the other ones are easy to get to if you memorize the one. Okay? The one to memorize is sine squared plus cosine squared equals 1. Okay? Now, if I go back, that should be logical. What type of triangle is that?
Right triangle.
Right triangle. All right triangles, you can solve for missing sides using whose theorem? Pythagorean's theorem. If I use Pythagorean's theorem on this, would you agree that sine squared theta plus cosine squared theta equals 1 squared?
Yeah.
That would be Pythagorean's theorem, right? Sine squared plus cosine squared equals 1 squared. Well, what's 1 squared? 1. So wouldn't it make sense then that our first Pythagorean identity is simply sine squared theta plus cosine squared theta equals 1. Okay. One quick thing on notation, guys. When you see this, sine squared theta, it means the sine of theta squared. When you see sine squared theta, it means this. Find the sine of theta, get that answer, and square it.
So why are they right at
So we don't have to use parentheses. If you put the 2 right here, wouldn't it almost look like you need to take theta and square it first, and then do the sine of it? Okay. Alright, well that's not what we want. We definitely want to take the sine of theta, whatever that value is, and square that value. Okay, so then you got to write it with parentheses every time? to avoid writing it with parentheses every time, we just throw the squared right here on the sign. Because that's not, I mean, sign squared doesn't mean anything because the sign is not a number. So that's kind of how we write it so we don't have to put parentheses in there. Does that make sense?
Yeah.
Okay. If you want to write it with parentheses in the squared, you go for it. I don't care. Okay? That's good. But that's just not the way you're going to see it in a textbook. Okay? You're going to see it this way. This is the only one I remember. Okay? The other ones are too much alike. I forget which one's got the tangent, which one's got the cotangent. I don't have them memorized. Never have. Okay? But I know if I got this one, I can get to the other ones. Okay? I can get to the other ones. Think about your quotient identities we just got done doing. I'm challenging you here. Okay? Think about your quotient identities we just got done writing down. Look at your quotient identities. Then look at the next identity that's in the book. Tangent squared theta plus 1 equals cosecant squared theta. Think about your quotient or your reciprocal identities. Think about the identities we've done so far today. If I know this one, how could I figure out this one?
Plug it in for 1.
What do you mean?
Take sine squared theta or plus cosine squared theta. Plug it in for 1. Substitute in for 1.
So take this and plug it in for the one here?
Yeah.
But what I don't know this one. Like I don't know this rule right here. I don't have this rule memorized, so I guess I don't really know where to plug it in. I see what you're saying, you can substitute some stuff in, but I just don't, without knowing this, without knowing there's a tangent here and a cosecant squared here, I wouldn't know what to write. I'm asking you, if you got this, and the reason I left room right here is because I'm going to show you in marker how I go from here to here. Can anybody see it?
Wait, isn't...
There's something I could do to every term that would get me this.
Divided by cosine.
Maybe if I would write down the correct identity, that might help. Nobody's calling me on that? Come on, guys.
Sorry.
I make mistakes like once every 10 years. And you didn't even get a chance.
Just ready to fix that.
Thanks, Greg.
Yep.
Now maybe it might be a little bit more clear what you're doing to all 3 terms now that I've written the correct one.
Divide by.
Divide by cosine.
Divide everything by cosine squared. If you know this one, that's an easy one to memorize. Okay? If you divide everything by cosine squared, what's sine squared over cosine squared? Look at your quotient identity. Sine over cosine is what?
Tangent.
Tangent. Well, because they're both squared, it's not just tangent, it's tangent squared. What's cosine squared divided by itself?
1.
1. What's the reciprocal of the cosine?
Secant squared theta.
Secant squared. Okay? So again, as you could tell, I didn't do that on purpose, writing down the wrong one. I don't have them all memorized. Okay? I didn't mean to do that. But I don't have them all memorized. I tried to write down what I thought it was. But I write this one, and I can figure out the other ones. There's 2 ways to figure out the other ones. The first way, divide everything by cosine squared, and this is what you get. Guess how you get the third one? Divide everything by sine squared. What's sine squared divided by sine squared? 1. What's cosine squared divided by sine squared? Cotangent squared. And 1 divided by sine squared? Cosecant squared. Okay? So I'll actually spend a lot of my time, or if I have to work with any of these other ones, you'll actually see me probably write this in the top corner of my page and then do a little bit of work to figure out the other ones. You want to memorize all 3, you go for it. I just think it's difficult. I've been teaching for a long time and I don't have them memorized. Because I just use this one to figure out the other ones. This one makes sense to me. It's a unit circle, Pythagorean theorem, x squared plus y squared equals r squared. Okay? Now, Would you also agree, guys, on this top one, that sine squared is the same as 1 minus cosine squared? If I just subtract cosine squared from both sides, you'd agree this is true? Keep that in mind. This shows up a lot. If you ever see 1 minus cosine squared, you know you can just replace it with sine squared. They're the same thing. Cosine squared would be equal to what? 1 minus sine squared. So I'm just writing those here. These are also Pythagorean identities, but they come from the main Pythagorean identity, so just kind of be aware if you ever see those. Alright? Questions? Okay. See what you got. Simplify. Sin x plus sin x times cotangent squared x. So sin x plus the sin x times the cotangent squared x. You can simplify this all the way down to one trig function. Give it a shot. Work with a neighbor if you want to. Pick a neighbor, talk about it. Sure. Yeah, you could. Give it a shot. Yeah. These are ones you pretty much you have to show. You have to show what you're doing, one step to the next. So it's going to take some work. What are some of the first ideas you guys are getting? What are some of the things you're probably doing first? They're not either. You can't combine the sin x's because the second sin x is being multiplied by something. Nope. You can't combine those. You can't combine those because that's being multiplied by something. Other ideas?
Split up cotangents.
Split up cotangents. That could work.
And then take sine and put it 1 over.
Cotangent. X. Or
Then you just have
you divide by cotangent. You have sin x plus, or no, you have sin x divided by cotangent x plus sin x divided by cotangent x, which would be.
Why divided by?
I thought it was tangent at first, or cosine, so I was thinking it'd be a tangent, so I could just poke holes in my theory. In their theory.
Other ideas?
Could you, so split up the cotangent
To what?
to cosine squared over sine, or no.
That is what I would almost recommend always to do. Try to write everything in terms of sines and cosines, because then stuff will start to cancel. Okay? What is cotangent squared going to be? What? Cosine squared x over sine squared x. Because cotangent is cosine over sine, right?
Then you're cancel out the sine.
That could cancel one of those. I think you're rolling. Go. See if you can finish it.
And then
That probably would have been my first step, or if I did separate it into two cotangents, like you said, Derek, I would have just had two more fractions. I would have had cosine over sine and then another cosine over sine right next to it, which then you would have noticed one of the sines canceled, like we said. But that's why I kind of said,
Can
yeah.
you cancel if one of them is a square?
It'd be like saying, can I cancel? Can I cancel this 3 and this 3?
Yeah.
Yep.
oh yeah.
So you'll still have.
I'll still have that 3 left.
So you still have cosine over. It'll be sine.
You'd have cosine squared over sine.
just be canceling out one of those signs?
Yep. So then I'd have sine x plus what?
Cosine squared x over sine x.
Mm-hmm.
So what are we supposed to, what are we trying to get it to?
Go like as low as you can go.
Now I'm stuck a little bit. Right?
You can put sine x over 1 with that.
It does actually. In order to add them together, what do I need?
Have the
Common denominator. To give it a common denominator, what do I need to do to that first fraction?
square or not, multiply by
Multiply it by.
sine x. Sine x.
What is my common denominator?
Sine x.
Sine x. So I need to multiply this by sine x over sine x.
Oh, so it's gonna end up being like a
So you get sine x squared over sine x.
Because I'm not changing anything, right? When you multiply the top and the bottom of the fraction, I don't change the value of the fraction. So now I have sine squared x over sine x plus cosine squared x over sine x.
That'd be sine squared x plus cosine squared x all over sine x, and that'd be 1 over sine x.
Nice. Sine squared x plus cosine squared x over sine x, because now that I have a common denominator, it's okay to add my numerators together.
1 over sine x.
This is 1. So I have 1 over sine x. And what's 1 over sine x?
1 over sine x is
Cosecant x. And you're done.
Wait, how'd you make that jump from the big fraction to that?
From
No,
here to here?
no, from there to.
From here to here?
Yeah.
What's sine squared plus cosine squared equal?
1.
I can replace sine squared plus cosine squared with simply the number 1. So when I have sine squared x plus cosine squared x, that's really equal to the number 1, so I can make my numerator become the number 1, which gives me 1 over sine x, which is simply cosecant x. Trig identities.
It's like
Drew.
I was just curious,
Yeah.
when would we use this?
Right. Honestly, it's mostly used in simplifying derivatives and antiderivatives, which show up in calculus class all the time. That's which I'm guessing probably then therefore could be transferred to some sort of maybe an engineering or something that you're going to do in the upper math fields. But it's more for you to understand how to simplify things, simplify trig expressions, which will make them easier to do derivatives and integrals in calculus, to be completely honest with you. Because yeah, in calculus, if I would tell you to potentially find the derivative of this, it wouldn't be terrible, but to find the derivative of this is much more complicated than finding simply the derivative of this. And this is really this. I'd rather just do the derivative of one single thing as opposed to a larger function. So that's really what it comes down to. You'll see a lot of trig in calculus.
How hard was that equation for like for this section?
Oh, what?
How hard was that for this?
That's a tougher one. They're definitely a lot more easier ones, but
Can we do an easier one?
I start you off big.
Bigger go home?
Yeah.
Common sense.
4.